Look up at the night sky. The vast expanse above us has always been a source of inspiration and curiosity. That familiar, silvery orb, the moon, has always inspired wonder. Its craters and plains tell a story of cosmic history. We've walked its surface, planted flags, and dreamed of more. The Apollo missions were just the beginning of our lunar journey. Now we're planning to stay, and that means we need serious power. Establishing a permanent presence requires sustainable energy solutions. NASA's next leap? Installing a nuclear reactor on the moon. This groundbreaking initiative will provide the energy needed for long-term missions. This isn't just engineering, it's the start of a new era in space exploration. The technology developed here will pave the way for future interplanetary missions. The first space race was a sprint, a race to see who could reach the moon first. This one's a marathon, about building a lasting human presence beyond Earth. It's about creating a sustainable way of life on another world. Whoever masters lunar power will shape humanity's future in space. The ability to generate and manage energy on the moon is crucial. Imagine a lunar village, astronauts living, working, and exploring, all powered by a steady energy source. This vision is becoming a reality. Running a base on the moon means powering lights, computers, life support, everything we take for granted, in one of the harshest environments imaginable. The challenges are immense, but so are the rewards. NASA's answer: harnessing the atom. Nuclear power offers a reliable and potent energy source for our lunar ambitions. This bold plan is turning science fiction into reality. The dream of living on the moon is no longer just a dream. The dream of lunar bases is no longer fantasy. It's a real engineering goal. Each step brings us closer to a permanent human settlement on the moon. The nuclear reactor is the first step to making the moon a permanent outpost. It's the foundation of our future lunar infrastructure. It's a declaration we're ready for our next giant leap, not just for one nation, but for all humankind. This endeavor unites us in a common goal. The moon is our proving ground for life beyond Earth. It's where we'll learn to live and thrive in space. The universe is watching as we prepare to power our future among the stars. Our success on the moon will be a beacon for future space exploration. The atomic age on the moon is about to begin. A new chapter in human history is unfolding right before our eyes. Why not just use solar panels? After all, they work so well for us here on Earth, powering homes, cities, and even satellites in orbit. But on the moon, things get a lot more complicated than they seem at first glance. A single lunar day lasts 29 Earth days, meaning 14 days of continuous sunlight, followed by 14 days of pitch-black, freezing darkness. During those 2 weeks of night, solar panels can't generate any power at all, and the temperature plummets to minus 173 degrees Celsius. Storing enough energy to last through the entire lunar night would require massive battery farms, so large and heavy, they'd be nearly impossible to launch from Earth with current rocket technology. What we really need is a power source that works around the clock, no matter the conditions on the surface. Nuclear reactors can provide that, delivering constant, reliable energy for heat, light, and life support, even during the coldest, darkest nights. Plus, some of the moon's most valuable resources, like water ice, are hidden deep in craters that never see sunlight, making solar power useless there. Only a nuclear reactor can power rovers and equipment for missions into these permanently shadowed, resource-rich regions. Solar energy is fantastic on Earth, where the day-night cycle is short and predictable. But on the moon, it simply can't meet our needs for long-term survival. Nuclear fission offers the robust, dependable energy we need to build a true home away from home, supporting habitats, research, and exploration. To survive and thrive on the moon, we must master technologies that work in the harshest, most unforgiving environments imaginable. In the end, nuclear power isn't just an option. It's the key to unlocking humanity's future in space and turning the moon into our next great frontier. So, what does a lunar nuclear reactor actually look like? How do you build a power source that can survive the harshest nights in the solar system? Forget Earth's massive power plants with their sprawling cooling towers and endless networks of pipes. NASA's Kilopower project is building a compact, efficient reactor, about the size of a paper towel roll, small enough to fit in the back of a pickup truck, but powerful enough to light up a lunar outpost. It's simple, with very few moving parts, and designed for maximum reliability, crucial when repairs are nearly impossible on the moon. Inside, enriched uranium fuel starts a controlled fission reaction, releasing a steady stream of heat energy. That heat powers Stirling engines, ingenious devices that turn heat into electricity by using expanding and contracting gas, with almost no wasted energy. The result? Steady, reliable power for a lunar base, even through the long, cold, 2-week lunar night when solar panels are useless. NASA, the Department of Energy, and private companies like Lockheed Martin and Westinghouse are racing to perfect the design, each bringing unique expertise. Multiple teams mean more innovation, more creative solutions, and ultimately better technology for surviving on the moon. The concept was proven in 2018 with a successful ground test, showing that this technology can really work. Now the challenge is to make it work on the moon itself, where conditions are even more extreme and unforgiving. This miniature sun could power humanity's first real home off Earth, lighting the way for a new era of lunar exploration and settlement. Why the rush to power the moon? It's not just about exploration, it's about global competition. The US Artemis program aims to build a sustainable lunar base, but China and Russia have their own ambitious plans. China is planning an international lunar research station and wants to land astronauts by 2030. Russia, with its deep space expertise, is partnering with China, forming a powerful alliance. The first nation to establish a permanent powered outpost will gain a huge strategic edge. Reliable nuclear power is the backbone of any lunar settlement. In this new space race, energy is the ultimate currency. Is it safe to launch and operate a nuclear reactor on the moon? NASA has built safety into every step. The reactor stays off during launch, the uranium is stable and subcritical. Even in a launch accident, there's no risk of a nuclear reaction. Once on the moon, the reactor is activated remotely, far from the crew. Its self-regulating design keeps it stable. If it overheats, it automatically cools down. After its mission, it's shut down and left safely on the moon, where radiation isn't a threat. NASA's decades of safe nuclear missions in space lay the groundwork for this next leap. If the first lunar reactor succeeds, it will change space exploration forever. 1 kilopower unit can run a small outpost for a decade. Multiple units could power larger settlements, labs, and even industry. With reliable energy, we can mine water ice, make air and rocket fuel, and turn the moon into a refueling station for deep space missions. The technology is a dress rehearsal for Mars, where solar power is unreliable. A compact reactor will be essential for surviving on the red planet. Success on the moon lights the way for human expansion across the solar system. This is the foundation for living off the land, building self-sufficient outposts, and reaching farther than ever before. The moon is our first step, Mars and beyond are next. The atomic age in space is just beginning. We're on the edge of a new era, one powered by the atom, reaching beyond Earth. This mission is about more than technology, it's about who we are as explorers. Building a nuclear reactor on the moon is a challenge of engineering, safety, and global cooperation. The benefits could ripple back to Earth, inspiring new energy solutions. But we must ask, is this the right path? Are we ready to be responsible stewards of other worlds? The universe won't give us easy answers. It's up to us to decide how we light our way. What do you think? Is atomic power the dawn of a new age in space, or a risk we should reconsider?